So in this section, we're going to go over graphing for cubic function. Now, the best thing when it comes to graphing is you identify the vertex. So when it comes to graphing cubic function, it's going to be very similar to absolute value. So the rules will be the same as what we did for absolute value and quadratic. In order to identify the vertex, the rule for x coordinate and the rule for y coordinate will be opposite x and same y. So once you apply the rule, if you're given the equation, it will be easy to identify the vertex. So let's take a look at example 17. So example 17 is m of x equals the cube of x plus 6 and then plus 2. So the opposite x is with the number that's inside behind the x. So since it's plus 6, opposite of it will be negative 6. The plus 2 will be for the y, so same y, meaning that since it's plus 2, positive 2. So my vertex will be negative 6, comma, positive 2. So let's take a look at example 18. We have p of x equals the cube of x minus 5 and then minus 9. So the minus 5 is with the x, so opposite of x, so opposite of negative 5 will be positive 5. So the minus 9 is for the y, so same y, meaning that it's going to stay negative 9. So our vertex will be positive 5, comma, negative 9. So once you identify the vertex, you basically finish the first step on graphing. So in this next example, where we have the function h of x equals the cube of x minus 2 and then plus 1. So what we did in the previous two examples, now we're going to identify the vertex. So opposite x, same y. So x minus 2. Since it's minus 2, opposite will be positive 2, and the plus 1 is for the y, so same y, meaning positive 1. So our vertex is 2, comma, positive 1. So once you identify the vertex, what we're going to do is that you're going to put it in the center, in the middle of your xy table. So 2 over 2 for x and then 1 for y. Now, when it comes to cubic, what's different between quadratic and absolute value, we would have like 3 rows. But in this case, we actually have 5 rows. So that means that we're actually going to have to find 5 points. But since you found the vertex, that means that you just have to do the work for 4 points. Now, since we have to find the other x value and 2 is in the middle, then it will be easy to identify the 2x value that's left and then 2x value that's right. So the 2x values that's on the left will be 0 and 1, and then the 2x value that's going to be on the right will be 3 and 4. Now, in order to find the y value, you just simply plug in the x value and then just follow order of operation, follow PEMDAS, you will find the y value. So let's start off with x equal to 0. So here's the work. All I did was, when you find h of 0, you basically plug 0 into x. So that's why I have cube of 0 minus 2 plus 1. And again, you just basically plug in 0 into this x. That's why we have it like this. Follow PEMDAS. I simplify inside the parenthesis, which is why we have negative 2 to the third power. Now, since we're working with the third power, it's to your best ability or beneficial for you that you expand. So negative 2 to the third power basically means negative 2 times negative 2 times negative 2, and then you write plus 1. Again, the reason I want you to write it out is so that you can visually see your work, and here's why. So let's take a look at negative 2 times negative 2 times negative 2. So if you were to multiply this one at a time, so let's take a look. Negative 2 times negative 2, that's going to be positive 4. Hence, is why we have positive 4. And then you bring down the negative 2, and then you bring down the plus 1. Now you're going to continue multiplying because these negative 2's that we have up here, they were all multiplying together, so you're going to keep the same operation. So now 4 times negative 2, now we actually have negative 8. So again, 4 times negative 2, because this negative 2 came from here. And again, you can see that a negative times a negative times a negative will come out as negative. So negative 2 to the third power, or negative 2 times negative 2 times negative 2 will be negative 8. Now, I still kept it in parentheses in case if you have something to distribute outside. So make sure you be very careful if you have a number or a negative sign. Since I don't have anything to distribute, I will let go of the parentheses, bring down the minus 8, and then bring down the plus 1. So now we have negative 8 plus 1, which is negative 7. So this is going to be our y value for x equal to 0. So again, it's best that you expand when it's to the third power. As I stated before, it's going to be best for you if you expand whether it's to the second power or to the third power or higher. So that way you want to make sure that when you multiply correctly, you get the right number and the right sign. So the next one is x equal to 1. So we're finding h of 1, meaning that we're going to plug 1 into x. So we're going to simplify the inside of parentheses. So 1 minus 2 will be negative 1. So now we have negative 1 to the third power and then plus 1. So just like I said before, let's expand. So negative 1 to the third is negative 1 times negative 1 times negative 1. And as I stated before, we're going to multiply 1 at a time. So negative 1 times negative 1, that's positive 1. Then you bring down the last negative 1 and keep the same operation, which is multiplication, and then bring down the plus 1. Now, we have positive 1 times negative 1. We're going to have negative 1. And I'm going to bring down the plus 1. Again, the reason I kept it in parentheses is in case I have something to distribute from the outside. In this case, I don't have to, so I let go of the parentheses, bring down the negative 1, bring down the plus 1. Combine these two numbers, and it will come out as 0. So this is going to be the y value for when x equals to 1. All right, now I'm going to do the same process for x equals to 3. So we're going to plug in 3 into x. So that's why we have 3 minus 2 inside the parentheses. Simplify, it's going to be positive 1. So 1 to the third power is basically meaning 1 times 1 times 1. Don't forget about the plus 1 in the back. So if I were to multiply this 1 at a time, so the first two numbers, 1 times 1, is positive 1. And then you bring down the last one and keep the same operation, which is multiplication, and then bring down the plus 1. Now I'm going to multiply the 1's again one more time. So positive 1 times positive 1 is 1. And then bring down the plus 1. Again, I kept the parentheses just in case if I have something to distribute with a number or a negative sign. In this case, I don't have any, so I can let go of the parentheses and bring down the number, and then bring down the plus 1. So I actually have 1 plus 1, which is 2. So 2 is the y value for x equals to 3. Now we're going to do the last x value, which is 4. All right, so we plug 4 into x, which is why we have 4 minus 2 inside the parentheses. So when you simplify 4 minus 2, it will come out as positive 2. So 2 to the third power, you expand. That's why we have 2 times 2 times 2. Don't forget about the plus 1. Now we're going to multiply the numbers one at a time. So the first two number, 2 times 2, when you multiply, it's going to come out as positive 4. Bring down the last two, keep the same operation, which is multiplication. Bring down the plus 1. Now, we're going to multiply the 4 and the 2. So it's positive 4 times positive 2. It's going to be positive 8. Then we're going to bring down the plus 1. Again, I kept it in parentheses for the 8 in case I have something that I'm going to have to distribute or distribute with a number or a negative sign. In this case, I don't have to. So I'm going to let go of the parentheses, bring down the number inside, so the 8. Bring down the plus 1, so 8 plus 1 is 9. So 9 is the y value for x equals to 4. So once you finish identifying the points, the x and the y values, now we're just going to use these points to graph. So what we're going to do is I'm going to do the left side. So since this is the vertex in the middle, then I'm going to connect to these two corner points, 0, comma, -7, and then 1, 0. So here we have the graph. The orange corner point, or the orange dot, is for 2, 1. 2 for x and y for 1. The next point going to the left is 1, 0. So 1, 0 right here, the blue dot. And then the next blue dot is 0, -7, which is right here. So just like absolute value and quadratic, you want to start from the very middle, the vertex. So we're going to go from the middle through these 2 points. Now, once you finish graphing through these 2 points, and make sure to include an arrow at the end of your graph, we're going to go to the other side. Now, the other side, 3, 2, and 4, 9 is the right side. So it's going to be the points on the right side. And this is where you're going to see how the cubic function typically look like. So 3, 2, 3 for x and 2 for y. That's the first point on the right side. And then 4, 9, 4 for x and then 9 for y. That's the second point on the right. So again, always start from the vertex. And as you can see, going through the first pink dot through the second pink dot, you see how the other side of the cubic function look like. So this is what a typical non-reflected cubic function look like. So you want to be very careful when you're graphing, especially in the middle 3 points. You see how it's not a straight line, it actually curves. So once you understand that it curves, so if you have the vertex and you were to graph, the best way to graph is to identify your corner points. Now, in this example, I was just showing you the steps on how to find the 5 corner points. But once you identify the vertex, then all you need to do is identify the outer points. So you don't have to identify these 2 points because in the center, it's always going to be like this. One diagonally up to the right and then one diagonally down to the left. Again, for non-reflected. But for the outer points, you just basically go 2 x values to the right and then 2 x value to the left. So if 2 is in the middle, so 2 numbers to the left is 0, and then 2 numbers to the right is 4. So once you find the outer points, then you simply, again, graph from the vertex when you go into the right side, and then graph from the vertex when you go to the left side. Again, this is what a non-reflected typical cubic function look like.